This is a short video for information analysis and decision making, probability and decision trees. This is an example of a probability tree where we're going to demonstrate the probability outcomes of flipping a coin 3 occasions. So we start on the left over here. And we don't have to do this in a very formal sense. It's quite intuitive, but in a sense, if we make sure this pen works properly. This flip one again. Usual apologies for the handwriting. Hopefully it will work out. On the flip one, you toss a coin once. Basically, you're going to have one of two outcomes. It's either going to land on a head, or it's going to land on a tail. Now, in principle, I suppose if you have a deep piled carpet, you could flip the coin and it might end up head on. But basically, we ignore that and we assume it's going to come out like that. So we've got two possible outcomes. And we don't even need to think hard about it to know that the chance of either one of these is coming up is what we would call 50-50. Okay. If we were representing this in formal probability terms, then we'd write a small p in brackets and h, and then we would write 0.5. Yes, that's a 0, 0.5. If we wrote down the probability of it coming up with a tail, that would also be 0.5. And it's no surprise to find that means that the probability of one or the other coming up is 1 or 100%, which means one of those outcomes has got to be the one. So if we then go to second flip, now, in the second toss of the coin, we throw the coin the first time, it comes up head or tail, and then we flip the coin a second time. And regardless of what it came out with on the first go, then on the second flip, it can still come out as a head or a tail. And what we're going to show here is the idea that we can represent the probability of two sequential flips. So if it did a head the first time, then effectively the second time it could come out with a head, or it could come out with a tail. If we flipped it and it came up a tail, the second time, it could come up a head, or it could come up as a tail. What we've got then here is if we look at the sequence of two flips together, then we've got actually 4 outcomes where it could be a head followed by a head followed by a tail followed by a head, and a tail followed by a tail. So in this first instance, we said that was 50-50. Again, if these are all seen as being equally likely, then each of those outcomes, those 4 outcomes, each has a chance of 0.25 or 25%. So we write it down again. So if we said probability, just take one example, a head followed by a head will be 0.25. And we could write the other 3 down there, and they would all be 0.25, which again would mean that the chances of any of those coming out would total 1, because one of those outcomes has got to be true. Doing it the third time, handwriting's going already. Flip 3. Again, going off this is the third sequence then. Regardless of what happens in the first 2 throws, when we throw it a second time, it could come up as a head, or a tail, or a head, or a tail, or a head, or a tail, or a head, or a tail. Okay? So we've got now 2, 4, 6, 8 different outcomes. Okay? One out of 2 there. 1 out of 2 from each of those, 1 out of 2 from each of those. And again, we can start to represent these as being the sequence. Head, head, head. Head, head, tail. Ooh, get it right. Head, tail, head. Shit. Head, tail, tail. Tail, head, head. Tail, head, tail. Tail, tail, head. Tail, tail, tail. So, tossing the coin 3 times gives us 8 possible outcomes. Any one of those outcomes is equally likely. As long as the coin is a coin that doesn't come up more on one side, no, it's not weighted or cheated or anything like that, then each of those outcomes has a probability value of 0.125 or 12.5%. And again, if each of those outcomes is equally likely, then what this does is this set of 8 here represents the complete range of outcomes that you can get from throwing the coin 3 times. And each one of those has got a 12.5% chance of happening. Now, we can do some slightly more sophisticated probability calculations based on this. So, for example, if we were to say what's the probability of throwing the coin that each time we throw it, we get the same thing 3 times, then there's 2 ways that we can get that. Either this way, 3 heads, or this way, 3 tails, which gives it 2 chances in 8, because there's 8 outcomes, and only 2 of those are ones where the 3 are the same. So the outcome for that is a quarter. Okay, we can do it again, for example, move to the principle of at least 2 heads. All right, so these are outcomes. How many of these outcomes do we find at least 2 heads? I would say there's 1, 2, 3, 4. Okay, so out of the 4 potential outcomes, then 4 of those have 2 heads. I'll show you again. 1 there, 1 there, 1 there, 1 there. And you can mess around with this all different kinds of ways. But essentially what it do is we can represent all the potential outcomes that were going to occur by doing this 3 times. We will find this principle useful when we come to the decision tree, when we will see that if we are trying to express all the possible outcomes of a potential course of action, then we represent it in this kind of format. It's important that we understand that we can represent the full range of possibilities that are going to occur given certain events. Now, we won't do this many, but in essence is the same. The key part to this is that if you look at any stage, however many outcomes there are, the probability of any one of those happening, which is the idea that we add them all together, and they must equal 1 or 100%, because one of those outcomes must occur. Okay.